Pulse amplitude modulation, that is PAM. This is a type of pulse modulation. We need BFW 10 FET and a 100 kilo ohm resistor to construct this circuit. This is the circuit diagram of a PAM modulator, and these are the waveforms. So first we have to connect BFW 10 FET on a breadboard. It has 4 terminals: source, drain and gate, and a shield or body terminal is also available. Here we are using only 3 terminals: source, drain and gate. We are not using the body or shield terminal. First connect the source terminal, then drain and gate on a breadboard. Then connect a 100 kilo ohm resistor to the gate terminal. So on the right side you can see the gate terminal. This is the 100 kilo ohm resistor. Connect it to the gate terminal. So here we are giving a message signal, that is modulating signal as a sine wave with 5 volt amplitude and 100 hertz frequency. Now connect a input message signal and then connect a sampling pulse, that is our carrier, which is its amplitude is 15 volt and frequency is 1 kilohertz. Connect it to the gate terminal through a resistor 100 kilo ohm. Now input message signal and sampling pulse signal both are connected to the circuit. In order to observe the waveform on a DSO, connect channel 1 of DSO to the input and then connect DSO channel 2 to the output. Here we are taking the output from the drain terminal of BFW 10 FET. Now the connections are completed. This is the message signal, sine, amplitude 5 volt and frequency 100 hertz. This is the sampling pulse, 15 volt amplitude and 1 kilohertz frequency. Now on DSO you can see both input message signal and output PAM, pulse amplitude modulated signal. This is the input message signal, sine wave with 5 volt amplitude and 100 hertz frequency. Use cursor to measure the amplitude. Here the amplitude is peak to peak voltage. Now you can see the PAM waveform. Measure the amplitude of PAM waveform using cursor. So this is basically a pulse modulation. Amplitude of pulse will vary in accordance with the input message signal. Here the input message signal is a sine wave with 100 hertz frequency, and the width of this pulse will be the same as that of sampling pulse, input sampling pulse. So in order to observe the sampling pulse, connect DSO channel 1 to the gate terminal. Now you can see the sampling pulse and output PAM waveform. So the width of output PAM will be same as that of input sampling pulse, that is the pulse which is applied to the gate terminal of FET, and the amplitude will follow the amplitude of message signal, that is the sine wave which is applied to the source terminal of FET, and we are getting the output from drain terminal of FET. Now you can see both input sampling pulse and output PAM modulated wave. So give a sampling pulse to the gate of FET. So in order to make a pulse waveform, adjust the DC offset of function generator.